Two lines are said to be parallel. Two lines are said to be parallel if they do not cross each other. That means that if one line does not cross each other, then we say that those two lines are parallel. Or we can say if they do not meet, even if you extend them indefinitely. So the word indefinitely means if you extend them as far as you can go, those lines will never meet at all. So if lines behave in such a way, we say that those lines are parallel. So parallel lines basically don't meet just because they have the same gradient. So in our yesterday's lesson, we looked at the gradient of a line, which is represented by letter M. So they don't meet because they have the same gradient, or call it slope. Another word for gradient is the word slope. So examples of parallel lines are here in this diagram. The line 1, 2, and 3. You can clearly see that these lines will never meet anywhere. They will never meet anywhere and are not crossing each other anywhere. So these three lines are said to be parallel. They are said to be parallel, and they also have the same gradient, which is represented by letter M. So they have the same gradient, and therefore they will not meet at any point in time. Okay, so for example, if maybe we are to consider to see if they have the same gradient, consider line 1. The line 1, it passes through the point. There is this point here and this point. So line 1 passes through the point -3, 0. And it also passes through the point 0, 2, which is the point up here. So if you have to find the gradient of line 1, remember we said for gradient, it is the change in y in the y-axis, which will be given by y2 minus y1 divided by x2 minus x1. So if we consider this to be y2 and this x2, then this is y1 and this is x1. So the value of gradient will be given by y2, which is 2, minus y1, which is 0, divided by x2, which is 0, minus x1, which is -3. So end up getting the answer as 2 minus 0 is 2, 0 minus -3 gives us 3. So the answer is 2 out of 3. So if again we have to consider, line 3. Line 3 passes through the points. There is this point here, which is 0, 0, -2. And it also passes through the point 3, 0, 3, 0. So if you have to find the gradient, which is M, to be given by y2, still the same formula, minus y1 out of x2 minus x1. If we go ahead and substitute, this is y2, which is 0, minus y1, which is -2, divided by x2, which is 3, minus x1, which is 0, and the answer is 2 out of 3. So you can clearly see that we've got the same value of gradient. For line 1, the gradient is 2 out of 3. For line 3, the gradient is 2 out of 3. So clearly, when lines are parallel, they do have the same gradient, and that's why they will never meet at any point in time. They don't intersect at all because they have the same gradient, or call it the slope. The slope of the lines is the same. So even if you are to find the gradient of line 2 here, you will still get the same answer as 2 out of 3 because those lines all have the same, gradient. That's why they will not meet at all. Okay, so we have another example question here. Using points A, B, C, D, show that the line AB is parallel to the line CD. Show that line AB is parallel to the line CD. So to show that two lines connecting 2 points or connecting points are parallel, you just have to show that their gradient is the same. We show that the gradient of those lines is the same. So meaning that we shall first find the gradient of the line AB, find the gradient of the line AB, which connects point A and B, and we also find the gradient of the line. We also find the gradient of the line CD, So, so the two lines will be parallel if the gradient of AB is equivalent to the gradient of AB is equivalent to the gradient of CD, then we say that those two lines are parallel. Okay, so let's first find the gradient. Let's first find the gradient of AB. The gradient of AB. So to find the gradient of AB, remember AB connects point A and point B. So we shall still use the same formula. If I call it M1, the gradient of AB is M1, it will be given by still the same formula, which is Y2 minus Y1 out of X2 minus X1. We can consider this to be Y2 and this to be X2, then this to be Y1 and this to be X1. So this will be given by 7 minus 4 divided by 8 minus 2. And the answer that we get from here, 7 minus 4 gives us 3, and then 8 minus 2 gives us 6. So the gradient of this is 3 out of 6, or in decimal point form, it's 0.5, or if you reduce 3 out of 6, you get a half. Okay, so we can go ahead and also look for the gradient of CD. So if I call it M2, it will be given by Y2 minus Y1 out of X2 minus X1. Okay, so this will be equal to, this is D, this is C. So still we can name our Y2 and X2, and also we name Y1 and X1. So this will be given by 5 minus -1 out of 19 minus 5, out of 19 minus 5. Yes, this is 19, this is 5. So when we get 5 minus -1, I'll end up getting the answer as 6. Then 19 minus 5 gives us 14. Okay, so the answer that we get is 6 out of 14. So if we reduce this, we end up getting 6 by 2, this is 3 by 2, this is 7. 3 out of 7. So you realize that the answer for the gradient of this is 0.5, and the answer for the gradient of this one is 3 out of 7. 3 out of 7, if we put it in decimal point form, let me try putting it in decimal point form. It is around 0.443. So since M1 is not equal to M2, then then we conclude that the two lines are not parallel. That means that AB, and CD, AB and CD are not parallel. So if we had got M1, being similar to M2, then we would conclude that the line AB and CD are all parallel. But since M1 and M2 are not equal, then those two lines are not parallel.